Alright guys, let's get some 1/2 inch finished up. I have got a ton of wire to finish in a couple days because all this dadgum rain. Stuff driving me nuts. It rained again today too. But I'm working on some 1/2 inch today. I got 2 runs of 1/2 inch flex to do. I finished the 7/8 run, finished another 1/2 inch hardline run, and I've got 10 more 1/4 inch flex runs to do. I'm going to try to see what all I can get done tonight. You guys are my motivation, so sharing with y'all is what keeps my butt out here. Waving a hand. Hope you guys are having a good week so far. Lots of stuff going on over here. I've got building a new bench very soon, so that's going to make me pretty much shut down operations for a while to build a new bench, because this bench, hopefully, if it works out properly, is going to replace 4 of my other benches. So it'll be nice. So, waving a hand, whoever else is on here. I didn't get to see who all joined. It's been a while since I went live. Y'all missed the 7/8 because I finished it up before I was fighting the weather. It was about to rain, so I hurried up and got it done, and y'all couldn't hang out and watch it. This guy needs 2 UHF connectors, PL259, for some 1/2 inch flex. What I'm doing is this is not a normal style setup. I don't suggest anybody who's not experienced in this to do this, but I'm making another connector work properly on it. It's really nice because of the composition of the connector, which allows me to do this. These are like unobtainium here. I've got 1 left after this, and that's it. I do come across them every once in a while, but they're few and far in between. So this fella needed it. So to be honest, I'm not charging like they're unobtainium. I mean, I probably should, because I probably won't have them anymore. But whatever, I don't really care. I'm not doing this to try to make a bunch of money. But I gotta get this one done. Then I gotta do a DIN connector and a split feed on another 1/2 inch flex wire. And then after that is going to be the 9 1/4 inch flexes. Yeah, I know, man. It's just talking about rain. Between today and tomorrow, I'm going to try to do my very best to knock out every wire that I've got left to do. I've already stopped taking in orders. The sale stopped on the 5th of August, so I didn't take any more orders in since then. I did allow 1 person to kind of squeeze in there on a maybe, but otherwise I haven't taken any extra work on, and I'm not going to until late August or so. So got some changes coming. Good changes though. I'll try to look up every once in a while and see if y'all say anything. What's up, Paco? Waving a hand, man. You're actually on the docket for this evening, so you'll oh gosh, this first one right here will definitely have to be wrapped up smaller, and there's the next one right there, and then some more flex. Come over here. just knocked over the very thing I needed. That's how that always works when you're doing stuff like this. Alright. Alrighty. So, y'all guys got any questions, feel free to ask. I'm just doing a little bit of wire work, so nothing much new to me. What's up, 43? Waving a hand, man. Yeah, this is some 1/2-inch flex right here. I don't know who else is hanging out. I know quite a few of you guys are in there, but nobody else is commenting, so I can see your pictures, but they're a little too far away for me to pick who you are. So, waving a hand, whoever's hanging out. Y'all some night owls over here. Well, I guess if you're on the East Coast, you are. Alright. Alright. Not doing much talking for this exact piece right here. What I'm doing is bonding the shield to the actual jacket. It doesn't have to be done on many types of connectors, but when you're doing a retrofit, it's going to have to, just because that's the best possible way to make contact. It still has a really nice crimp, but anytime you're ever doing anything out of spec, if you have the ability to make it stronger, then make it stronger. If any of you guys plan on using this wire to its full potential, don't order UHF. Go a bigger connector. DIN connector is the next size up, and it is the way to go. You can get it on your bird meters, you can get it on your colossal 10Ks, maybe the 25Ks, I don't remember which one it is. You can get it on your shockwaves. Every one of these antenna builders sells this connector. So if you do plan on going something bigger that needs this wire for power handling wise, then definitely go ahead and get the bigger connector, because this UHF connector is only really rated at about 6 kW peak. There have been many people to go over that rating, but what I'm talking about is sustainability, not one-time operation. So, just in case you guys don't know what that stuff is, I've got a whole box full of them right here. I needed that anyway. This is, for you guys, the difference between a UHF or PL259 whatever, there's the bullet for it, larger UHF that I'm using right here, which is the same connector. The back is larger to work for a bigger wire, and there's DIN. So that gives you the difference between the two of these. So definitely best to upgrade if you have the ability. If you don't, what? Get. Go. I'll talk to mommy about it later. Alright. Little ones always getting themselves in trouble. Alright. So this is one of the few larger connectors that has a solder on type. There's not many large connectors that really go solder on the larger pieces, just so you're aware. A lot of you guys look at my some of these other connectors and like, you didn't solder that? They don't work the same way in high-powered RF, and when you get in FM broadcast and above, most of what they're doing is compression style. Alright, you will find the occasional L45, L44, L47 does not solder. L44P. I also have another little unobtainium piece. There's a neat one. Yeah, I'm making some half. I'm making what's left. Alright, there's just something pretty neat. That is an LC for 1/2 inch. So, just happen to have one of those. Realistically, the 1/2 inch runs out before the LC connector would. Yeah, I'm making pretty much the last of my stock here, Mark. This is what I've got left from the orders that were already made. I haven't taken on orders since the 5th of August. It has been, and then realistically before that, that's just when I cut off the sale. Let's put this over here. You can always test fit anything you've got. It really doesn't hurt anything to do so. So really a neat little trick with this stuff is just chop it until you get the right fit. So anybody who follows the millimeters to the T, when they do that, you're gonna find and realize that as you tighten up some of these connectors, it don't line up the way they say. So don't get too scared if you have to modify something. Basically, you just kind of got to use common sense. If you look and see, hey, there's no way this center conductor is going to be in the right position if I do this, don't do that. I don't care what the instructions say. There's something that was lost or missed in that step. Sometimes they don't talk about the recession of the jacket itself, because a lot of times you're actually recessing back into the foam more than you think you are. So those millimeters that they're mentioning are millimeters that you're not accounting for. So just a FYI. So this is my little evening time thing. Ain't much going on but building some wire. So you guys can feel free to hang out. Y'all are what's keeping me working. Otherwise my lazy bum self would be going inside right now. I got to get some stuff accomplished. So it makes me accountable when you guys are here watching me. And also, this is the only opportunity I've had in the past, I don't know how long, that it hasn't rained. And believe it or not, it actually has rained today. It's just stopped raining long enough earlier for me to actually be able to come out here and do something. Ugh, freaking weather, man. Not been enjoyable. Jughead was telling me something about bad rain coming around. Well, I think somebody said the weather is supposed to be bad the rest of this entire week, so not really looking forward to any of that, but it is what it is. No, the only, sorry, the only DIN connectors I have are these. And this DIN connector is a compression style, but it's made for 600. I thought it was going to be good for multiples, and this is what I thought I had. But no, I don't have any other connectors at this moment. Unfortunately not. The only DIN I've got is for 1/2" flex, 1/2" hardline, 7/8 hardline, 1 5/8 hardline, and LMR 600. That's the only DIN connectors I have for wires. I don't have any for 393 right now, unfortunately. I thought I had some, but I do not. I was mistaken. Alright, so I need a jack, but I don't have one. Alright, so that's got this one taken care of. I'm gonna go ahead and put some heat shrink on it. Y'all can watch that, and then I'll move on to the next connector, and you guys will see, or the next wire actually, and you guys will get to see that. I've already cut a piece of heat shrink, good lord. Alrighty. Alright, so that's the fun with that one. That one is done. Now, that does not mean that wire is complete. That means that wire is ready for wrapping. I have to unspool each one of these spools, wrap them up much smaller, and then pack them. So, a bit more work left to be done there, but the wire is complete. So, that's wonderful news for me. It's 1 down, 10 to go. Next is here. Where, oh where? There you are. Alright. Now, here comes the next one. This is going to be a mess on my bench, good God. So this, I'm one of those people that's at least a decent amount OCD. I can't say I'm a clean freak, but I am not this messy. Unfortunately, I've only got so much bench space and so much workspace and so much time. So I have to prioritize the most important piece of that, and the most important is finishing it. If I get off on another task, I will start cleaning for about an hour and won't get nothing done. So I'm just gonna go ahead and complete what I need to get done, stress myself out about my dirty workbench, and clean it later. So that'll be the fun. So it is what it is. Alright, so any of you guys who've asked me questions about getting wire, asked if they could do it themselves and stuff, they've got little instruction manuals you can follow and stuff. So if you do follow it to some degree, on some connectors it will work. On retrofits, it does not. So kind of keep that in mind, be careful. Also make sure it has the right writing for your type of wire. Don't be trying to build something for some LDF5 for some AVA. That will get you in a world of trouble because you'll make a mistake. So if you look right here, this one right here is different. I don't really need these, but I mean, you guys would probably enjoy them. So that gives y'all a little bit of something. So it's not impossible to do this stuff, especially if you can just follow directions. A lot of you maybe some of the new guys that are in here and some of the guys that I haven't mentioned to before might think that I'm trying to keep all this business for myself as far as building these ends. I really don't mind. The reason I do these videos is so you guys can watch me, and this can kind of be a little bit more normal and not the end of the world to build and do. So maybe you guys will do it yourselves. I sell just the connectors. I've got probably 150 some odd connectors at least. So I really don't mind. It ain't no big deal to me. If you guys want to just get the connectors and stuff. The reason being is, I mean, it's really fun to see people upgrade. And I don't want it to be a stigma out there that, oh no, getting a new wire is terrible. It's hard. It's difficult. It's not really that difficult. Don't psych yourself out. So, anybody's thinking about doing it, do it. I mean, well, now, don't be doing it with me for a little while, because I'm not going to be taking in any orders for a bit, so sorry for that. Late August is when I will be back. So, just so you guys know, not the fact that I don't like you guys, it's just the fact that I've got to get a bench prepped. And I want to be able to have a little bit of time to at least make it somewhat customized to me. It does not have to be a finished product for me. I'm not that picky, but it's going to be nice. It's about, I would say, well, one, it's the only place that I can actually have a space that's large enough for me to work inside of a building, so that'll be nice. So I'll have an air conditioned setup, and I think I'll have about a 15 to 20 foot bench, so I'll have quite a bit more space, so that's always nice. Alright guys, here comes the fun. Got to get to work. You are the one I want. If you guys got any questions, feel free to pop them in the comments. I will try to look up as I can. If somebody has asked me something already and I did not see it, feel free to ask again. I don't have to be the only one rambling on here. I can always respond to something if y'all got any questions. Alright. Nobody's asking anything, so I guess I'll keep working. What I'm doing now is basically tying on the jacket for this wire right here. So measure, make sure. A little over. So much. You can always make a cut. You can always make modifications before you finish up with something. So don't look at something like it's the end of the world if something doesn't measure out exactly what you need. Take it apart, start over, do it again. It's not that big of a deal. I mean, usually when you guys start a project, you've got a bit of a weekend to work with, you've got some time, so make it happen. Don't give up on the project just because something looked a little hard. All I'm doing now is just clean the foam off of this. It is not really that big of a deal to have that foam there. So, alright, so I need to do from here All I'm doing is deburring this edge, because the last thing I want to deal with is any. If you've ever had a sharp edge and you've run something down on that sharp edge, what happens is it leaves a bunch of shavings. It's the last thing you want to do inside of a connector. So always do some sort of deburr. Even if it's nothing super advanced, just do something. That right there actually was pretty much all that connector needed. So as far as deburr goes. Alright, so I will go ahead and delve into that since it's a question, no problem. Alright, easiest way to explain this is going to be not an easy explanation, guys, so bear with me. If you're getting lost with what I'm talking about, then just kind of move on to looking at what I'm doing and not what I'm saying. It might be hard to follow. Alright, if anybody's ever looked at what a Smith chart is, a Smith chart has a revolving scale. It has a impedance set point, and it has a inductive and capacitive reactance that it's set on the chart. So that follows a pretty definitive scale. I think, who is the guy? No, not WI2HY. I can't remember his daggum name. I'm sorry. He's the applications engineer for Tektronix. He kind of goes over it a little bit, and it's the best explanation I've seen so far in layman's terms for people to follow. What happens when you're actually modifying a coax or running a coax length is you're nulling the coax out to a specific length. See, whenever you cut a coax at velocity factor and you're cutting for a specific wavelength, what that does is decides what particular degrees out of phase it is. If you've ever looked at a sine wave, what a sine wave is a peak and a trough. You got a peak that goes up, goes back down to a center point, goes back up to a center point. So at each one of these peaks and troughs, there is a point that it follows on a Smith chart. So as it goes up and down on the peaks and troughs, as it hits its peak, you start at one of the Smith chart at the null, you go all the way up over to the Smith chart to the other end, to the trough, or to the, excuse me, from the center point to the peak, back to the center point. So what that is that's 90 degrees on this side of the Smith chart, and 180 degrees on the other side of the Smith chart, then 270 degrees, then 360, and so on and so forth, multiples above. Where it's at on that Smith chart determines what kind of reactance it's going to have, and also how it's going to interact with your system. They make what's called quarter wave stubs, and they're what's called a matching stub. So you can use a open end of a quarter wave connector or wire, piece of wire, as a tuning stub for multiple things, especially at higher frequencies. So coax does have an effect, and it's very important to pay attention to how it does. If you're trying to keep the same readings and not trying to transform or change or do anything with tuning, and the only way you'd be able to do that is for certain types of cavities and certain types of stubs. Don't be mistaken what I'm saying by being coax length. At that point, the only way to get the same reading from one end to the other end is to be exactly at that 180 degree, 360 degree, and so on and so forth, multiples thereof, of that particular wavelength. So when you're at half wavelength, you're at the null, at the trough of the sine wave. So at that point, there's no capacitive or inductive reactance that would actually be affected in the line to trick equipment. So the best guy to watch is to watch closely on that video. It's hard for me to explain fully. A lot of times what I'll do when I do a write-up for people is, in order rather than sitting here trying to explain in a way that I may somehow mess up or somehow misinterpret myself, I try to come prepared and then do a write-up for you guys. I've done it before. I may do another one on coax length just to kind of bring it out to the in layman's terms. A lot of guys can see a lot of technical jargon and get really confused with it. I saw someone reference in the same video of that individual telling me that coax length mattered, and then another guy saying that coax length didn't matter, referenced in the same video. So don't get too confused. I'll just try to break it down. There's a reason for every length that we run. So that's the easiest way to explain it without putting it in a full video. But your half wavelength is what I would pick. If you're, now here's something else that will get really confusing. Your amplifier, whatever amplifier you have, whatever amplifier you own, bought, pill box, whatever, even tube box, depending on what type of tuning network it runs, is not going through to the antenna. So any individual who says, well, I've got a 1.0 on my antenna and it doesn't matter what I run in between my boxes because I've got a 1.0 on my antenna, it's fine, everything's good. No matter what your antenna is, that's a completely different subject, because as soon as you turn that amplifier on, or even as soon as you put the amplifier in line, you're no longer checking at the antenna. You're checking, one, through a bypass tune, which is close to checking directly to the antenna, but it's not the same. Or you're checking through the input tune of an amplifier. Any pillbox amplifier has the absolute most simple input tune that you've ever seen in your life. It is not complicated. It literally uses the length of the coax specifically in that network because of the way it's designed as its tuning reference. So the reason being is most builders will have a specific length of coax on their bench. They'll tune that capacitor out, and that capacitor along with that particular coax length is what makes the tune for the input of the box. You can make a much more complicated network, which is much easier to deal with, or even have a variable capacitor there where you can actually change the coax length. But the right way to do it is do like a pi L network, or there's multiple other networks you can build with. Getting a little too complicated. Let me try to make it easier. Try to find a way to say this better. Without a proper tune network, you're going to have a specific length of coax based off of which builder builds your box. So if you ever wonder why this builder says run 12 foot, this builder says run 6 foot, this builder says run this foot, it's because that's usually what that builder's running on their bench, and that's what they tune with. Now you could change that tuning capacitor and you could actually modify how your input's set up, but that's generally the reason that the length matters. And then also that's generally the reason that some of these single stage capacitor tuning networks on tube amplifiers do not tune out as low as some of the dual knobs. The reason being is you have less range and less adjustment for different variations. See, so and then also, to give you all an even crazier thing, output impedance is affected by the voltage that you run the device at, and also the drive that you're putting, the output that the device is doing. So that means that your tuning, unless you have a broad-banded amplifier that's going out to your antenna, even your output tune on your amplifier changes with different power levels. So a little bit too much information, but maybe it'll get you guys thinking at least. It's not something I'm not trying to solve the world or get the whole world's problem solved all in one I know everything statement, because absolutely I have more to learn, and I'm constantly digging into the subject myself. As I have a absolute understanding of it, I can then bring it to layman's terms for somebody else. That's kind of the essence of this stuff. A lot of these engineers who spent a lot of years learning this stuff, I don't understand why exactly, but they just, rather than breaking it down for someone into something simple, they want to keep it complicated, maybe, just because I guess if somebody was smart enough, they could technically put them out of a job. But really, if they thought about it, they've spent so many years in the job, in their career, and spent so much time and hours learning this stuff that the average Joe's not really going to figure it out, even if you do break it down to them. So it's not like I'm trying to. I don't understand what their deal is, to be honest. But I'll try to break it down some way. I want to get into that stuff because there's a ridiculous amount of rumors out there. And I'll give y'all something to learn while I'm there. Alright, so I did not discuss this. So with most people, what I'll do is build about this much feed line length. Let's do this. Hang on a second. I need to do a measurement on this. Got a little ahead of myself. You guys seeing me do all this work. Here's where I get into the rest of it. I can kind of cheat a little bit. I have to do a little bit of math while I'm sitting here. I've got that one prepped at least. Alright. Starting point. This wire right here has actually got a meter length on it, so I can kind of cheat a little bit and just work out the last little bit. So, in case you guys didn't know the conversion, just for the math, 3.2808 is the conversion from meters to feet. So, a good formula and a good number to keep in your head. Of course, you can always look it up over and over again, but that's a good number to remember. And also, another good number to remember, which is going to be harder for some of you guys, is going to be 299,792,458. What that is the speed of light. You will use that a lot. So, the reason being is because RF travels at the same speed as light because it's part of the electromagnetic spectrum. So, 39.5. And so I need this. Now, one thing I am not is a human calculator. I cannot do that. So, go right here. 249. So 4.1. Write this down. 4.1. Alright, then we do alright, so basically pretty much 34. So 34, 3.9 something. No, equals plus over here to 176. 176. So 209.93958799053. No, don't have to get that particular, but just so y'all know. Alright. So, let's take a look. Nice. So, I've got 40. 39. Let's measure one more time. Let's get this little one out, y'all. In case you didn't know, I have stuff everywhere. So, forgive me. If you guys are not interested in what I'm doing, then just bear with me, because I'll get back to building here in just a second. But I got to do some numbers. So 39.5. So here's the math for this. 3.2808 times 12. So it's 39.36 inches. So 39.5 is going to be 0.36. So I have a third of an inch over here. So third of an inch over right here. So I take 75. So 11. 39.93. Write that down. 39.93. 3 times 3.05. No. Equals times 12. 36.61. 36.61. Okay. So here's the math. So 39.93. So I'm going to take 175. 175 plus 214.1. Whoa. Yeah, you ever seen a wolf spider? You want to see one again. I don't like that booger. Might go squish him. So I'm kind of being a little boring right now, guys, but I just want to go ahead and double check some numbers. So 1, 2, 4 equals 33.93. 33.93. There we go. Plus 175. 208.93. So 208.93. That was a third of an inch over, so a third of an inch. Under. 208.93. This is the boring part of my job. 93. Times 12. Divided by 0.39.36. All right. What's that? 208.93. All right. 5. 208 is right. And over here. All right, so what I'm squabbling over right now is about 3 inches. So that's what I've got to figure out the math on. So that's why it's taking me so long to convert all the different math. If you really wanted to get super particular, I guess you could roll the whole thing out and measure each individual thing, but you're double working yourself, because all you have to do is figure out the last foot. So, not the last meter. So that's my boring stuff. Waving a hand, man. Evening, and whoever else. So, a vacuum is what's the speed of light will travel in a vacuum. Yes. RF travels the speed of light through anything, through a vacuum at that speed. Anything else that has what's called velocity factor, it will slow down to a certain degree. So here's my boring part, my 5 minutes worth of math, because I forgot to cut this beforehand. I normally cut this stuff before. So 208.93. So 0.93 times 3.208 equals times 12. So 36.61, 36.91. 36.91. So basically 37 inches. So I have to go back to the previous meter and do 37. So here's the fun. So 37 is pretty much right here. So normally, if you're building a connector, you'll chop it right here. So what I'm going to do is not do that. So what I do is I'm actually building a terminal. So if I'm building the terminal, I have to cut it back to whatever the terminal's length is. So usually I do about, since you're in here, and there's not too many other people, Paco, what length do you want? If you want, we can do 6, or I can do less if you don't think you'll need more. Most of the time I do a split feed that's about yay long. So you'll have about this much to work with, so you'll be able to work a distance about this far apart. If you would like anything else, I will wait just to be sure and see if you want to do anything else. While I'm doing that, I will go ahead and double measure, and then we will cut. So I'm gonna wait for a second. Just right at the 6. 6 is good. Okay. So what I'll do is I'm going to go ahead and make the cut for this. I have a bigger set of cutters, but whatever. So this is on the money what if we was building a connector where I would stop at. Since we're not building a connector, I'm going to measure this off and then cut from there. A lot of people get confused about the wire that they're running. and they want to try to build at the end of a connection and or at the end of a wire and not the end of their final termination. So even here I'm going to have to get a little bit more particular, because what you measure at, it's not that, but this. So if I'm technically working something out, it would be, you don't have to get super particular about this, because you can be within an inch or two of the other, of one side or the other, and it makes not too much difference on the system. But I mean, who knows? I figured y'all get a kick out of seeing me having to do all kinds of stupid math. I've already did previously the actual math that it takes to figure this out, but what I do is I work it by the frequency that we operate on. If you want to do the math yourself, you have to know the speed of light, which is 299,792,458 meters per second. What you have to do from that point is take your meters per second, which is the speed of light or the speed of electromagnetic waves, and then you take that measurement. You can convert it at that point if you wanted to, but really you just divide it by the frequency that you're going to operate at. So if you want to operate directly in the center of the band, you would set it for directly at the center of the band. If you want to operate it on a specific channel and you want to have the most accurate readings on that specific channel, then you will set it for that specific channel. You don't really have to get that specific. As long as you got it usually within about a half megahertz, it's still fine. That's about 40 channels wide, or 50 channels wide, just so you guys know. I haven't seen any significant difference one way or the other, so don't have a whole lot to comment on that. I would be interesting to see the minuscule differences between each piece one way and the other, but I don't have the time nor the effort to dig that deep into it. So if one of you guys do, please share the results with me. I would love to share it with other people. But once you divide it by the frequency that you want to operate on, at that point you get a full wave measurement. So say we operate at 27,205,000 hertz directly on channel 20 of the CB band. If you wanted to use that as a set point of frequency, you have to use hertz. You cannot use megahertz. You have to use hertz. So you divide that by, like I said, 27,205,000 hertz. At that point, you will go to the next step, and you'll have a full wave meter readout of your desired frequency. At that point, you figure out your half wave, so you divide that in two, you get a half wave reading of that setup. So at that point, at a full wave, you'll get 11.08 or some odd meters. So at that point, well, here you go, I'll just give you some math. You guys are here, so might as well. 299,792,458 meters per second. Divide that by 27,205,000 hertz. We get 11.019 meters. So that's what our full wavelength is for that given frequency in meters. So if you want to convert that to feet, at that point in time, you do times 3.2808, the other measurement I told you. You get 36.15 feet. You want to figure out what half of that is, you get 18.076 feet. So anybody who's ever said, you have to have an 18-foot piece of coax to make something work, that's where it came from, because it actually is a half wavelength at 27,205,000 hertz of the 11 meter band. It's directly in the middle, 18.076 feet. Hey, 18-foot coax, I've heard that a bunch of times. Problem is, that's in a vacuum. So a whole step of math that's completely missing from the formula there. So that's where most people screwed it up, including manufacturing companies like Firestick and other companies. They literally they don't specify the type coax it needs to be or anything like that, so it's literally just misinformation they're spreading out on the market. Crappy, but true. So the magical, wonderful, special thing that everybody forgot is something called velocity factor. Velocity factor is what the speed that RF can travel through a dielectric. So this is a certain type of dielectric, this foam polyethylene or whatever the heck they use for this particular coax. There's a bunch of different polys to them. PTFE is Teflon. Polyethylene, I think, is what 213 runs, and then there's foam poly something for this stuff. But each one of those has a specific velocity factor. It's not the wire, it's the dielectric. A lot of people get that confused. So going forward, let's go put this on here real quick and measure this one more time. If you was to say 213, the velocity factor for it is 66%. If you was to say some forms of hardline, it's 91%. Others is 88%. So it just depends on which wire you're running. This particular wire that I'm using right here specifically has a velocity factor of 88%. So if I factor that math into the mix, what I would get is 15.9075 at that point. So I would actually do that math until I got the other number that I need for this. So every half wavelength is 15.90 feet on this wire. 0.90 is not 15 foot 9 inches. 0.90 is 0.90 times 12. So that's how you figure out your inches. A lot of people get that stuff confused for whatever reason. I don't know why. So that's my soapbox and long explanation of nothing. So actually, no, it's not nothing. I don't want to demean how important that is. It's definitely important to know these numbers. A lot of your guys will just tell me to know it, and they don't care if I explain it to them or not. Other guys would like to know this information, so I don't mind sharing it. Maybe we'll knock out the 18-foot piece of coax or the 3-foot increments mess. 3-foot increments actually does specifically work for a quarter wave and a half wave of 66% velocity factor coax. Pretty well, to be honest. I mean, because it's actually 11 foot 11 1/4 inches or so on some 213, and then half of that would actually be what just under 6 foot. So that's actually 12 foot and 6 foot. That actually does follow 3-foot increments there. A lot of people get confused because of stuff like that. Just because one specific coax has a close number like that does not mean other coaxes will have close numbers like that. So all depends on the velocity factor. Alright, so this is I've got a bunch of 1/4 inch jumpers I've got to finish after this one. I doubt that I will complete them this evening. It is I will complete this wire. This wire will be done this evening. Then I've got to wrap up a 170-foot wire, and then I've got to wrap up this 111.349 inches, not 0.349, yeah, whatever, 0.349 feet piece of it. I will be working on that. Depends on how much rain we get and if I can secure a good helper. But as soon as I can get me a good helper that will help me wrap these things up, I will get that taken care of. I've got 2 more wires that's already packed up and ready to go. They just got to go out the door. And then I've got, like I said, 9 more jumpers, and then I am complete and caught up. Alright. What I do is usually take a bit of an extra step whenever I'm doing this wire. You do not have to do this if you build your own, but I just like to do it just because I feel like it's a better connection for me and for the customer that I'm building for, I usually make sure I'm always contacting at least 2 different points on the wire. That way, if there's ever this solder is not a mechanical connection by any means. It is never designed to be, never supposed to be used as, and was never meant for being a mechanical connection. But the least I can do is make it as durable of a connection as possible. It is an excellent electrical connection. A lot of people get those simple little details mixed up sometimes, and that can kind of really bite you in the butt. So if you keep that in mind when you're working with this stuff, stuff will last you and work very well and do a good job. But if you treat this like it was a heavy crimp, then you'll just have premature failure. Doesn't mean it's not going to be stout and last for forever. It just does mean exercise caution when you're working with solder. You little booger. This wire gets really hot really fast. Even so much so that my hand can't quite handle it. So, something I've got to figure out how to deal with. So, I want this to stay. I'm going to have to hold it with something. Thank you very much. What I'm doing right now is trying to maintain a good dielectric spacing. That's important when you're working with a wire like this. And also, watch out for any sharp edges. I'm going to be a little bit more particular about this just because it's irritating me. I'm kind of one of those people who just doesn't give up sometimes. Especially when something just a little closer. It's like a 1/16 of an inch closer than I want it to be, but I don't mind being picky because it's my job. There we go. Cool. Much happier with that. So, alright. So next piece is to get the rest of this wrap on here. I'm doing kind of like a sleeve wrap on this. Alright, if you guys had any questions, feel free to ask. I'm kind of definitely doing something doesn't require a whole lot of thought right here. This is just the last of this connection, just making sure I'm bonded properly all around the edge of the jacket. I want to make sure that I've got a good connection that will last for years to come. So that's the I went ahead and did 3 on this one. Might as well. So from that point, here is the fun. Just take the feed line, same point, and measure. So do this. Just bugs me. There it is. Nothing's there. Almost on the money. So I can be particular here and chop. Pretty much what I want. So yeah. This is just a press fit. Don't consider this a crimp. A lot of people will look at this and say I crimped it. It's not a true crimp per se. True crimp is going to be like 6 tons of pressure. Depends on what wire you use, of course. The pressure depends on the specific one you're using. Alright, so here we go. Let's do this. Hey, y'all can't even see, man. Y'all need to tell me this stuff. Here I am way over here. Y'all can't even watch what I'm doing. Lord. Pardon the no haircut. This corona mess and extra working is really making it difficult to get my haircut. And the last haircut I went to, I had to wear a freaking mask. Didn't even do no beard trimming or nothing, so that was pointless. I'm all fine and dandy with a haircut, but jeez. It's always nice to go somewhere and not have to do something yourself. Now, of course, I can do it myself, but really, to be honest, I just really didn't care for wearing a mask inside of a daggone haircut in place. Couldn't even cut my sideburns very well. I had to pull the mask off partially for the sideburns. That was so retarded. But yeah, that's just... have to wait until all this mess is over, and then maybe we can get back to getting the haircuts again. And besides, I'm working every bit of the hours that it would take for one of those places to be open. Now, you can seal this with whatever method you want. I generally use this method because I like it the best. It seems to work pretty well for me. It really is not super particular how you want to do this. I like to use a adhesive lined heat shrink for my outer, and then use a heat shrink on each one of my braids. I have to reach way too far. Oh my goodness. Now I've been robbing these. I'm gonna have to get my own soon enough. Just adhesive bond. Yeah. So let's see if we can make this Will this work? I always try to find new tricks to make something work. Whether it will or not depends on if that trick's a good idea or not. So. In case you didn't know, with stuff like this, it's fairly difficult to get a long piece of heat shrink on one of these wires. It's not really an easy task. It's worthwhile because it's nice to have it all covered the whole way. I know guys who never even heat shrink their braid, but I like to do it. Ta-da! Dang, that was close. Let's pick the first piece of heat shrink. Okay. Next is this one. And there it is. Weed eater. Copy that, D-man. Get some weed killer in your hair. Alright, so a little bit further. Need more. Can't wait till all this stuff's over so we can go back to enjoying the breaks and having some fun. We're actually having a little swap meet at the shop, so you guys feel free to come. We're still going to do it regardless of this stuff, just because, I mean, it's going to be fun. We do it every year, and so y'all are more than welcome to come. Announcement will be made, oh Lord, August. We should probably make it probably in the next week or two, to be honest. I've already got it as an event set up on my page, but we've got to confirm one more break and make sure that we're not crossing schedules with them, because that's one of the only ones that's happening this year that I know of, and I don't want to conflict with them, because I would like to go to that one. Alright. Alright. So as a marker and nothing else, take a little piece of white heat shrink. Put it on the hot connection. It does absolutely nothing but identify the hot wire. If you guys saw that other piece of heat shrink that I just brought up here and maybe knocked on the ground, that would be wonderful. Do. All that time, got the heat shrink and everything, and there's my little light. Blind you guys in the middle of the night. I have no clue where it went. It may be sitting right here in front of me, but I am not about to dig. It is too late. It's probably sitting right here in front of me. But I'll go back and watch the video and see if it fell or knocked it off the bench or something. So, no, around this time was when I... Oh, there it is. Ha. Ha 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 ha. That's what I get. Sing the I'm an Idiot song. Y'all ready for this? Check it out. Let's put this back before I forget. Bam. There it was. Whew. Alright, so pretty much that's the gist of this. All I gotta do is I'm gonna fill this up with glue. That'll seal that connection off. The heat shrink is adhesive lined. The glue is just basically to maintain dielectric spacing and also keep water and moisture and things like that out. You can cut every bit of this off and put what's called silicone 2 compound on here. That is just a outdoor type of silicone. It's designed to be able to be used. It is not a structural silicone, it's just a sealing silicone. So that's something that can be used on this also. I've seen it used before. I've got to wait on this to heat up and then I am done. So I'm going to go and kill it, guys. I know you guys were hanging out till the end for me, but I'm literally here at the end, so I'll catch you guys later. This is going to be done before this evening's out. Then I'm going in and going to bed. And then at it again tomorrow, and then tomorrow's going to be 1/4 inch day. I've got 10 of those to build, and then I'll be done and finally caught up, and then maybe posting some updates on the new bench soon. We'll see how it goes, and I'll kind of keep you guys posted. I'll make some posts in there. I may do some build process videos, but I'm not sure, to be honest. Depends on how intricate I decide to go with the build. Don't really have much of a budget on the build as far as a budget limit. It just really depends on where I want to go and how far I want to go with it. Alright guys, I'll catch y'all later. Y'all have a good evening. See y'all. Appreciate it, Paco. Appreciate it, Larry. See y'all. And whoever else might have been watching or watching this later.